Hey, it's time for dilations. So dilations you might think of with your eyes. If you ever go to the eye doctor and you shine a light on your eye, they try to dilate your pupil. It makes it bigger or smaller. That's what I think of right away with dilations. But you know what? I couldn't find a picture that didn't look weird of eyes. So I'm not going to put a picture of eyes on here. But for today, our learning target is to be able to dilate points and shapes on a coordinate plane. So we're going to talk about what basic dilations are, but specifically I want to work on doing it on a coordinate plane, so on a graph. A few things I have here for success criteria that will be helpful. One is simply to know that a scale factor is a number you would multiply by to shrink or enlarge an object. So we're going to get into that a little bit. You'll also be important to know that a scale factor greater than 1, so like 2, means you're enlarging something. A scale factor less than 1, so like 0.5, can't have a negative one. 0.5 would mean you're getting smaller. So let's think. What is a transformation? Well, so far we've learned, we've talked about the different types of transformations, but basically, as a review, a transformation is anything that will change that will move an object. It will change how an object is, whether it's rotated, translated, dilated, or reflected. So all the things that we're dealing with are transformations. And today's transformation is a dilation. So here's a key vocabulary term for you to write down. To dilate, or dilation, is a transformation in which a figure stretches or shrinks with respect to a fixed point. And our fixed point that we're going to be dealing with is the origin of a graph today. So, with that being said, how do we dilate an object? Well, if we refer back to our success criteria for today, we talked about a scale factor. So we're going to have to use this thing called a scale factor. So a scale factor, here's our second vocabulary term for today. A scale factor is the ratio of a side length of an image to the corresponding side length of the original. In other words, we're going to put in parentheses the number that you multiply by to enlarge or shrink. So what I mean by that is you can look at it two different ways. If you're going from this object, this smaller object, to the larger object, smaller to large, it's getting bigger. So to get from 3 to 6, you might know that it would be times 2. So our scale factor equals 2. Now, if you don't know that it's times 2, if you didn't realize that 3 times 2 gets you to 6, to figure that out, you just go backwards, and you can do the scale factor would be 6 over 3. It's the ratio of the second one to the first one, 6 over 3, which does equal 2. Now, if it was going the opposite way, if it was going from the larger to the smaller, the scale factor is going to be opposite of it. So if we think about the fact that we said you do the second one over the first one, the scale factor for this one would be 3 over 6, which actually equals 1/2, or 0.5. And maybe you knew that already, because if you go from 6 to 3, you'd have to multiply by 1/2. It would be the same thing as dividing by 2, but we're looking for what you would multiply by. So our scale factor would be 1/2, or 0.5. So that's what a scale factor is. It takes an object and you multiply by it. So you multiply by 6 by 1/2 to get to the new object of 3. Now on a graph, it's slightly different. So this is an important note to have. How to make a dilation. Use the given scale factor. So that would be our step 1. If we had a scale factor of 2, we would multiply each set of coordinates by that scale factor. That's our step 2. So all we're doing is multiplying. It's just a basic multiplication lesson because multiplying by something makes it bigger or smaller. So in other words, if you have the points x, y, and you know the scale factor is k, we're just going to use a random thing because we don't have a number right now, it would be kx, ky. If it was, let's say we actually had numbers, 2, 3, and our scale factor was 2. To figure that out, we would do 2 times 2. Oops, let me erase that one. And then the scale factor 2 times the 3. And we would get our answer of 4 and 6. That would be our new point dilating with a scale factor of 2, making it 2 times larger, or in this case, 2 times farther away from the origin. So let's practice that a little bit. We've got 3 examples. I'd like you to at least write down 2. If you need to grab graph paper, please do so, or make your own, but you don't necessarily need graph paper for dilations. So it says, I know it says example 2, but we're 1 off. Draw a triangle DEF with points D, which is negative 3, 2. I'm going to draw it, negative 3, 2, so over 3 up 2. 1, 2, so over 1 up 2. And 1, negative 1, so over 1 down 2. There's my triangle. We want to make it a dilation with a scale factor of 3. It means it's going to be 3 times bigger, and all the points are going to be 3 times away from the origin. So to do that, we simply draw the triangle, multiply the x and y coordinates by 3. So I do that with each one. I'm going to do times 3, times 3, times 3, times 3, times 3, times 3. So to get my d prime, we talked about d prime would be the second, the image after you do a dilation. D prime would be negative 3 times 3 is negative 9. 2 times 3 is 6. So then for E prime, it'd be 1 times 3 is 3. 2 times 3 is 6. And for F prime, it would be 1 times 3 is 3. Negative 1 times 3 is negative 3. So if I were to graph it now, I'd have negative 9, 6. So negative 9, back 9, 1, 2, 3, 4, 5, 6 up. So I'm right here. 3, 6, so I go 1, 2, 3 to the right, and then 1, 2, 3, 4, 5, 6 up. And then 3, negative 3. 1, 2, 3 to the right, down 3. There's my new triangle. It is definitely an enlargement. That scale factor was greater than 1, so we know it's going to get bigger. And it is 3 times the size. And if you're not sure if it really is 3 times the size, look at one side of a triangle. So this side is 1, 2, 3. But on the larger triangle, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 3 times the size. So our last step would be to draw a triangle DEF. So it all had to do with multiplying. Let's go through example 2. So one with a scale factor that's less than 1. So this example says draw a triangle PQR with vertices P, Q, and R. Then find the coordinates of the image after a dilation of a scale factor of 0.5. So what we're doing, so I'm going to draw it first, just so like we can graph it. Again, if you don't have graph paper, you don't necessarily have to. You can do it without the graph paper. Negative 6, 6, and negative 4, negative 2. All right, there's my triangle. Okay, we're going to have to trust the scale factor here. Again, if it's a scale factor of 0.5, we multiply by 0.5. All of the numbers by 0.5. So, in other words, we're finding what half of the numbers are. So negative 8 is half of negative 8, or times 0.5 would be negative 4. And half of 4 would be 2. So for Q prime, take half of each of those, we get negative 3 and 3. And for r prime, we get -2 and -1. So if I regraph these, p prime would be -4, 2. -4, 2. Q prime would be -3, 3. Right there. And -2, -1 would be right there. So you look, it looks like the same shape, just a mini version of it. You'll notice it's not inside of the original shape. It's just closer to the origin, but it is going to make it half the size. All the side lengths are half the size. So that's how you go ahead and do, that's how you go ahead and use a scale factor to find new coordinates. So I'm not even going to graph this one, and if I just look at this, it's going to be a scale factor of 2. So I'm just going to do times 2 for all of the points. And you could find those out really easily. So, with that being said, let's go back and revisit our goals for today. Our goals are to be able to dilate points and shapes on the coordinate plane. And all we have to do for that is to multiply by the scale factor. So we definitely did that. To be successful, know that the scale factor is the number that you'd multiply to shrink or enlarge an object. So hopefully by now you got that we're multiplying. And anything that was greater than 1 made it bigger. If it was less than 1, it made it smaller. And that's what our work is for today. And that is dilations. Talk to you next time.